Hello and welcome to today's lesson, examining examples of energy transfer. In today's lesson, we will firstly understand the energy transformations that occur in various everyday scenarios, such as throwing a ball, breaking a car, and boiling water in an electric kettle. We will also identify the different pathways through which energy is transferred and transformed. So far, you are familiar with the concept of energy transfer and its pathways. We have discussed how energy can change from one form to another and how this transformation can occur mechanically or electrically. Building on this foundation, today's lesson will deepen your understanding of physics by illustrating how energy transformations apply to real-world scenarios. Understanding these processes helps us appreciate the principles of energy conservation and the different ways energy can be harnessed and utilized. Let us examine our first scenario, throwing an object upwards. When you throw an object, such as a ball, into the air, several energy transformations take place. Let's break this process down. Initially, the energy required to throw the ball comes from the chemical energy stored in your muscles. When you exert a force on the ball, this chemical energy is transformed into kinetic energy, giving the ball motion. The harder you throw the ball, the more kinetic energy it gains. As the ball rises, it begins to slow down due to the force of gravity acting against it. During this upward motion, the kinetic energy of the ball decreases. However, this energy isn't lost. It is converted into gravitational potential energy, which increases as the ball gets higher. When the ball reaches its highest point, it momentarily comes to a stop. At this point, all the kinetic energy has been transformed into gravitational potential energy. This marks the maximum height the ball will attain, and the energy is now entirely stored as gravitational potential energy. However, gravity continues to act on the ball, pulling it back toward the ground. As the ball starts to fall, this gravitational potential energy is gradually converted back into kinetic energy. The further the ball falls, the more its gravitational potential energy decreases, while its kinetic energy increases. As the ball falls downward, its speed increases, meaning more kinetic energy is gained. By the time the ball returns to the height from which it was originally thrown, nearly all of the gravitational potential energy has been converted back into kinetic energy. When the ball finally reaches the ground, just before it hits, its kinetic energy is at a maximum, and its gravitational potential energy is at a minimum. Upon impact, the kinetic energy can be transformed into other forms of energy, such as sound and thermal energy. The total energy within the system remains constant but changes forms as the ball rises and falls. The transformation of energy occurs through mechanical processes. The force you applied to the ball did work on it, converting chemical energy from your muscles into kinetic energy, giving the ball its initial motion. As the ball rises, gravity does work on it, causing the conversion of kinetic energy into gravitational potential energy. When the ball falls back down, gravitational potential energy is converted back into kinetic energy as gravity continues to act on it. Next, let's analyze the energy transformations when a car slows down. A moving car possesses kinetic energy due to its motion. When the driver presses the brake pedal, this kinetic energy needs to be dissipated to bring the car to a stop. The braking system of the car works by creating friction between the brake pads and the wheels. As the brakes are applied, this friction converts the car's kinetic energy into thermal energy. The brake pads and discs heat up due to the frictional forces, and this heat is eventually dissipated into the surroundings. Like the previous example with the ball, this transformation occurs through a mechanical process. The frictional force does work on the car, converting its kinetic energy into thermal energy. Through this example, we see another practical application of the principle of energy conservation. The kinetic energy isn't destroyed, but is instead transferred and transformed into another form. Finally, let's consider the example of boiling water in an electric kettle. In an electric kettle, electrical energy from the power source is transferred to the kettle's heating element. The electrical energy causes the heating element to warm up, which then transfers its thermal energy to the water, gradually raising its temperature until it reaches the boiling point. This process involves electrical energy being converted to thermal energy through electrical pathways. The flow of electricity through the kettle does the work, resulting in the transformation of electrical energy into thermal energy of the heating element. As the water continues to absorb thermal energy from the heating element, the temperature of the water rises until it reaches its boiling point. At this stage, the thermal energy being transferred into the water is used to break the intermolecular bonds, causing the water to change state from a liquid to a gas. In this case, the heating process is an example of energy being transferred through a heating pathway. The energy flows from the heating element to the water, increasing the thermal energy of the water molecules. This pathway is crucial in everyday applications like cooking, heating, and generating steam. This example highlights the difference between electrical and mechanical pathways, demonstrating how energy transformation can be achieved through electrical methods rather than mechanical ones. These examples illustrate how the principle of energy conservation plays out in everyday activities, showing that energy is constantly transformed but never lost. In today's lesson, we explored the concept of energy transformation and conservation through practical examples. We examined how energy shifts from one form to another in various situations, such as when a ball is thrown into the air, water is boiled in a kettle, and a car slows down. By analyzing these examples, we gained a deeper understanding of the pathways through which energy is transferred.